The half-life for a radioactive isotope is the time it takes for 1/2 of the sample to decay. It is also simply written as T 1/2. Now, how long it will decay depends on the isotope, because the half-life of a radioactive isotope is a property of that given isotope, and it's independent of the amount, the temperature, and the pressure. Independent means we cannot increase or decrease the rate of decay by changing how much we have, the temperature of the sample, or the pressure of the sample. So let's look at that definition again and see if we can figure out what it means. So half-life, 1/2. So it's the time, so it's going to have a time it takes for 1/2 half-life of the sample to decay, which means to go under its radioactive process. So look at this question. If you have a 160 milligram sample of technetium-99M, and the M is just telling me that it's not stable, it tells me here in the problem that the half-life is 6 hours. And half-lives of isotopes, since they're dependent on which isotope you have, can range anywhere from hours, like in this one, to tens and thousands of years. In fact, potassium-40 has a half-life of 1.3 times 10 to the 9 years. And uranium-235, one of the radioactive isotopes we use in a nuclear reactor, has a half-life of 7 times 10 to the 8 years. So the length of a half-life can vary greatly. So this question goes on to say that this technetium is used for a diagnostic procedure, and then the question is, how much of this isotope remains after, and then they give us an amount of time. So let's look at A. Well, the first time is 6 hours. And 6 hours, if you look here, is 1 half-life. So this is 1 half-life. So in 1 half-life, the sample goes down by 1/2. So if I had 160 milligrams, if I multiplied it by 1/2, divided it by 2, then I would have 80 milligrams left. So for this technetium, after 6 hours has passed, 80 milligrams of radioactive isotope will remain. Well, what about letter B? So this is 18 hours. Well, if each half-life is 6 hours, that means in 18 hours, we would have 3 half-lives. So that means it gets divided in half 3 times. So I can say 1, 2, 3. So 160 divided by 2 3 times goes down to 20 milligrams. So after 3 half-lives, if I started with 160 milligrams, I would be down to 20 milligrams. Now finally, let's say it goes for 24 hours. So 24 hours is 4 half-lives. Because if I took 24 and divided it by 6, which is the time they told me is 1 half-life, I would see that that goes into it 4. So if I have 160 milligrams, and if I had 4 half-lives, I would divide it in half 4 times. So 160 divided by 2, 4 times leaves me with 10 milligrams. So just like the name suggests, a half-life is the amount of time it takes to divide your sample in 1/2. Now here's another question, and this is similar to a homework problem. It says radioactive phosphorus-32 decays to form sulfur-32 by emission of an alpha particle. The half-life is 14 days. how much of each isotope, and look here, it says each isotope, is present after the time interval if we start with 124 milligrams of phosphorus. So what we need to remember is that during a radioactive decay, the sample is not disappearing. In fact, the total amount of sample will be the same. What is changing is the amount or ratio of each of the two different isotopes. So when we start out, we have this phosphorus 32. And so looking after 14 days. So 14 days is one half-life. So in 14 days, it's one half-life. I'll just put HL for half-life, the number 1. So my sample has been divided in half. So I'd have 124 milligrams times 1/2. And that would equal 62 milligrams. So at the end, my whole sample would be divided in half. And so I would have phosphorus 32. That would be 62 milligrams. And then the other sample, the rest of it would change into sulfur 32, which would also be 62. Remembering that the total sample always has to equal, these two things together always have to equal 124. So now let's look at the second one, letter B. So this is 28 days, which is 2 half-lives. So if I had 124 milligrams and I divided it in half twice, I would get 31 milligrams of my phosphorus left. Remember, I'm starting with 124 milligrams of phosphorus. So now I only have left 31 milligrams. This is of the phosphorus. Now the remaining, they want to know both isotopes, the remaining has to be the sulfur. So if I say 124 minus the 31, 12 minus 3 is 9. Sorry, 9. So I have 93 milligrams of the sulfur 32. So, excuse me, 93 plus 31 equals 124. So you see what I'm doing is figuring out how much of the phosphorus is going to remain, and whatever the difference between the 124 and the phosphorus, that's the sulfur. So let's say I have 42 days, which is 3 half-lives. So I would say 124 times 1/2 times 1/2 times 1/2, and it's going to be 15.5. Now, my guess is that would probably be rounded to 16 in your book, but we'll go ahead and put 15.5. I'm not 100% sure. So that's 15.5 milligrams. Oh, I'm trying to write something small and my pencil's messing up. And this is the phosphorus 32. And so then, thinking about what the sulfur would be, I say 124 minus 15.5. And that's a 0.5, 37, 107.5 would be the difference. I mean 108.5, because it has to equal 124. So I have 108.5, and this is the sulfur. So you see again, I'm figuring out based on the half-life the amount of phosphorus, and then whatever the difference is between 124 and the amount of phosphorus, that tells me the second isotope, or in this case the sulfur. And so 56 days is 4 half-lives. So I would say 124 times a half 4 times. And this equals 7.75. So it's even further. I can't even write it. This is the phosphorus 32, and it's 7.75. And then if I take 124 minus 7.75, I get 116.25. And that will be, these are all milligrams. I stopped writing milligrams. The sulfur 32. So what you can see, if I took the colored pen and look through, you could see for each half-life, the amount of phosphorus got smaller and smaller. And what was being produced is the sulfur, and so you'll see each sulfur, or each half-life, got larger and larger. And the total amount always had to equal 124. Now here's one last question, and it kind of backs into the idea of half-life. It says if the amount of the radioactive element decreases from 2.4 to 0.3 in 12 days, this wants to know what is the half-life. Well, I know the definition of half-life is dividing in half. So if I went from 2.4 and divided in half, that would equal 1.2. And if I divided it in half again, that would be 0.6. And if I divided that in half again, that'd be 0.3. Whoops. So here, to go from 2.4 to 0.3, it takes 1, 2, 3 half-lives. And the problem tells me that those 3 half-lives happened in 12 days. So 12 divided by 3 tells me that each half-life took 4 days. And so, what is the half-life? For this particular isotope, the half-life is 4 days. Half-lives can also be used for the detection or the dating of archaeological artifacts. In this course, we're not going to go over that, but that is an important way that radioactive isotopes are used.